All right. Hello, Honors Algebra 2. Here is what we're going to talk about today. I kind of mentioned yesterday, it's kind of a big day. What we're going to be talking about today is the fundamental theorem of algebra. So, here is our goal. By the end of today, I can explain the fundamental theorem of algebra in my own words by using simple polynomials and their graphs. What you're going to find today, I'm going to tell you to pause the video a lot, and the video shouldn't be very long. A lot of this is stuff that you kind of have to do on your own. I'm not going to show you all of the graph and calculator stuff, but I will show you some of it. That way you can get an idea of kind of what's going on. So, as a warm-up, what I'd like for you to do, I'm already going to ask you to pause it. What I want you to do is, for A, B, and C, I want you to graph each of the following polynomials using your graphing calculator. Then I want you to write the degree and the number of solutions, including multiplicity. Now, when we write the number of solutions, what I want to make sure you do, at least for right now, we're only writing down the real solutions. So we've seen that there are complex solutions, and we know how to find those for certain polynomials. For right now, I just want you to write down how many real solutions each of the following polynomials has. All right, hopefully you've had enough time to graph each of those. I'm going to go ahead and write down what the degrees are for each. So for the first one in part A, the highest exponent I see is 2, so it would have a degree of 2. For part B, it's the exact same. Degree is 2. The last one, the highest degree I see is a 3, so that would have a degree of 3. Now as far as number of solutions, when I graphed each of these, for A, it crossed the x-axis twice, so that would be 2 solutions. For B, it only touched the axis once, but had a multiplicity of 2. And then for C, the number of solutions, it crossed the x-axis 3 times. So here's the question. What are you noticing about the degree and the number of terms for each of the polynomials that you just looked at above? Is there a pattern you notice? Go ahead and write down your idea, and I'll write down what you should be looking for. Okay, here's what I'm hoping you saw. Hoping you started to notice that the degree and number of solutions is the same for each if you include multiplicity. So it was the same for all of them except for the middle one, but if you include that there was a multiplicity of 2, meaning that that solution happened twice, then there were still 2 solutions with a degree of 2. Okay, so let's do some more investigation with this. Let's see if it continues to hold. Meaning, let's look at the next 3 polynomials. Once again, when we write the number of solutions, I'm looking for the number of real solutions. So, what I'd like for you to do, go ahead and pause the video, graph D, E, and F, and do the same thing. Write down your degree, write down your number of solutions. All right, go ahead and pause it. In a little bit, we'll check in. All right, so taking a look at each of those. For D, here is your degree. It looks like our highest exponent was a 2, so we'd have a degree of 2. For E, it looks like the highest exponent I see is a 3, so I'd have a degree of 3. And then for F, highest degree I see is a 4, so there's my degree. For number of solutions, for D, it crossed the x-axis 0 times. For E, it only crossed once, and for F, it only crossed twice. So, here's the question now. Does your idea from above work for these polynomials as well? Explain why this might be the case. So go ahead and write down your idea, and I'll kind of mention what I'm looking for. All right, so did our idea work again this time? No, it didn't. If it did, we should have had 2, 3, and 4 as our number of solutions. So why might this be the case? Well, most of these, in fact, we know that some of these for sure would if we were to solve them, but it looks like most of these have complex solutions. In addition, to any real solutions. All right, so here it is. Here comes big idea for today. We're ready for it. Is this idea of the fundamental theorem of algebra. Here's what it says. It's kind of a two-part here. It says this: a polynomial of degree n, so some degree n, has at most n real solutions and exactly n total solutions including complex solutions and multiplicities. Also, and this is part that we might not have seen, but there is also at most n minus 1 turning points. We haven't talked about turning points yet. That'll be something we look at in the future here on Friday and Monday when we look at more of the graphs. But there it is. There is your fundamental theorem of algebra. So basically, in short, here's what it's saying. If you have a fifth degree polynomial, then you can have at most 5 real solutions, and you have to have exactly 5 total solutions if you include all of the complex solutions and multiplicities. Or if you have a polynomial of degree 2, you can have at most 2 real solutions and exactly 2 solutions if you include all the complex solutions and multiplicities. In other words, whatever your degree is, that's how many solutions you should be looking for. Some of them are going to be real, some of them might be complex or have multiplicities as well. So here's what we can do now. Take a look at G, H, and I here with me. It says for each polynomials, write the degree and number of solutions, including multiplicity, but do not graph necessarily. So I'm not asking you to graph them all the way, but you should be able to look at this and at least based on the number of real solutions, say how many complex there should be, as well as any multiplicity. So here we go. For the first one, go ahead and graph it. Pause the video if you need to, but it should have a degree of, it looks like 5. Now when you graph it, you see that there's only one real solution. It doesn't have any multiplicity. We know there should be 5 solutions in total, so that would tell you that there are going to be 4 complex. For H, your degree, the highest exponent you see should be a 6. So when you graph it, you see that there are 3 real solutions. It looks like one of them has a multiplicity, which gives you a total of 4, meaning that there would have to be 2 more solutions that would be complex for this one. The last one for I, this is kind of an interesting one. We don't always think about linear equations as being polynomials, but linear would have a degree of 1, and it looks like it only crossed the x-axis once, which is what should make sense. There's only going to be one real solution there. All right, so here's what we're going to do next. Now we're going to look at how you can solve polynomials even when they are not factorable. So steps to solving, here's kind of your different things you're going to do. You're going to be using graphing, synthetic division, and factoring or quadratic formula or some other method to solve. So step 1, it says you're going to graph. So you're going to use a graph to estimate any of the roots that you can. You need at least one real root for the next step. Now, the next step, synthetic division. That's going to be where you use synthetic division to prove the root. And then in step 3, factoring and quadratic formula. And sometimes I like to use completing the square. It's basically where you're going to solve the remaining equation using any method to find the remaining roots. Okay, so let's take a look at example A, where it says x cubed plus 2x squared minus 4x minus 8 equals 0. Now, this one does end up being factorable, but just for the sake of kind of working through the process, let's just kind of work through and see if we can figure this out. So, step 1 says that we need to graph this. So, on your graphing calculator, here's what you would need to do. Go to your y equals, type it in. So x to the power of 3 plus 2x squared minus 4x minus 8. And let's take a look at our graph here. And this one actually is going to turn out to be really kind of nice. Because if you take a look at it, you can actually already see where the two zeros are. You've got one right here, which is at negative 2, 0. Looks like it's got a multiplicity of 2. And then you've got another 0 at x equals 2. So for my solutions for this one, what you'd be saying, you'd say that there's a solution at x equals 2. We also saw that there was a solution at x equals negative 2. It had a multiplicity of 2, which looks like there was a total of 1, 2, 3 if you include the multiplicity, so 3 total solutions. So you had 3 real solutions. We had a degree of 3. At that point, you're done. You found all your solutions. So for this one, you only had to get through step 1. All you had to do is worry about the graphing part. Alright, well let's see what would happen if maybe that doesn't work out so well. So for example B, let's kind of change our polynomial now in our graphing calculator to be this, to be x cubed minus 6x squared plus 7x plus 2. Alright, so x to the third minus 6x squared plus 7x plus 2. Alright, and for this one, it looks like we're going to have 3 real solutions, but only one of them looks easily identifiable. It looks like the only one that you can see right away is this one at x equals 2. So here's what we're going to do. We're going to say that one of our solutions for this one would be that x is equal to 2, which is one of them that you're going to find using a graphing calculator. Now, because the other two looked like they're going to be decimals, they didn't look like whole numbers, we want exact values. So what we're going to do, step 2, it says use synthetic division to prove your root. In other words, what you'll do, use 2 as your division number, and then set up your synthetic division bar with your coefficients. So for this one, 1, negative 6, 7, and 2. And then let's double check and just make sure that 2 is actually a solution. Okay, so let's do our synthetic division here. And it looks like we do get a remainder of 0. So our new kind of equation that we have to work with. Once you've divided out that factor of x equals 2, you're left with this. You're left with an equation that says x squared minus 4x minus 1. That's kind of like your second factor. So what we need to do, we need to set that equal to 0 and try to solve using any method. Now, this one doesn't factor because you can't multiply to be 1 and add to be 4. So we've got two options. We can either do quadratic formula or we can do completing the square. I'm going to actually do this one by completing the square. It looks like it'll be kind of a nice completing the square problem. It's got leading coefficient 1. It's got a middle value or a middle coefficient that is an even number. So this one should go pretty quick for completing the square. You'd say x squared minus 4x plus some number minus 1 minus that same number is equal to 0. Think about what number this is going to be to complete the square. So to think about negative 4 over 2 squared, which is negative 2 squared, which is just 4, which means that you're going to just add and subtract by 4. So now, this piece, your x squared minus 4x plus 4, that'll factor to just be x minus 2 squared. Outside of it, your negative 1 minus 4 becomes negative 5, still equals 0. And then you can see it's a very nice problem for solving by square root. So then you just take x minus 2 squared equals a positive 5 when you add that over. Take the square root of each side. Make sure you include plus or minus with the square root of 5. And then just add your 2 over. And you get x equals 2 plus or minus the square root of 5. There would be your other two solutions that you're looking for. Now, those are the same solutions. If you prefer using quadratic formula, you can feel free to use quadratic formula as well. You just plug in all of your information, and there you go. On the answer key for the homework, you'll see that I like to use quadratic formula on a lot of those, which is fine. You can also probably do completing the square on some of them. It really doesn't matter. It's up to you how you solve it. But just know that a lot of times it's going to be a quadratic equation, and most of the time it's going to be one that you either have to use completing the square or quadratic formula for. Okay, so now let's talk about two other big ideas here that go along with our idea of the fundamental theorem of algebra. One of which is the complex conjugate root theorem, which is a big name that says that if a plus bi is a root of a polynomial equation that has real coefficients, then the conjugate, a minus bi, is also a root. So they come in pairs, is basically what that's saying. For the irrational root theorem, it basically says the same thing. If you have a plus b squared to c as a root of a polynomial with rational coefficients, then a minus b squared to c is also going to be a root. Alright, so the last part here, when we talk about multiplicity, that's just saying that there is a certain number of times a zero or factor, depending on what you're working with, repeats. In other words, if you have a multiplicity of 2, it means the 0 happened twice. If it's 3, it happened 3 times, and so on. Okay, so here is how we're going to use each of those. In A, B, C, D, and F, or A, B, C, D, and E, here's basically what we're going to be doing. It's going to be asking us to write a polynomial function p in factored form and in standard form by using the given information. Here's how that's kind of going to work. First, what you're going to have to do is convert each of your solutions to factors, meaning if you start with x equals 2, for it to be a factor, it'd have to be equal to 0, meaning that you'd have to subtract 2 from each side to get that x minus 2 is equal to 0. That'll tell you that one of the factors for your polynomial is going to be this. It's going to be this x minus 2. Now, the ones that are going to be tougher are going to be the fractions. So if you have x equals negative 3 over 4, to get this right side to equal 0, first thing I would do would be to multiply by 4 on each side and get that 4x is equal to negative 3. Then add by 3 on each side to get 4x minus 3 equals 0. You're kind of working backwards from your solution. So when you write your actual polynomial function, what you'd say, you'd have p of x is equal to, for factored form, just list out your two factors. So x minus 2, and then 4x minus 3. Now, it also wants it to be in standard form as well. So, for standard form, all that means is you have to do some distribution. So, go ahead, just as a warm-up, I'll let you practice that. Go ahead and work on multiplying out x minus 2 multiplied by 4x minus 3, and I'll write down what the answer should be so you can have a chance to check yourself. Alright, here's what you should have had. 4x squared minus 5x minus 6. So you've got two different forms here. If all I ask you for is factored form, here you go. You're done, you're at what your two factors are, and you're good to go. But oftentimes, we like to have stuff in standard form. So if it does ask for standard form, basically that means multiply everything out, and here's your standard form. So example B is going to be very similar, where you've got x equals 0. That one's kind of nice, because you've already got your factor. It's already equal to 0, here you go. For x equals 1/2, remember, you want to kind of work backwards, so multiply by 2 first, 2x equals 1, then subtract by 1 on each side, 2x minus 1 equals 0. There's your second factor. Third factor, x equals -1, so add 1 on each side, x plus 1 equals 0. Alright, so your polynomial p of x in factored form, just list all of those out, and the order doesn't matter. X, then 2x minus 1, then x plus 1. I also want you to write this in standard form, and again, I'm going to let you practice it. I'm not going to show you how to do it. I want you to practice and then check your answer with me. My only suggestion would be this. I would suggest multiplying out all of this first and then distributing x. It's just a little bit easier because when you distribute x, then it's at the end it's just kind of nice. You've already simplified and you only distribute 3 times instead of 4. Just an idea, but it should work no matter how you work it. Alright, go ahead and go. And then I'll write down answers, so if you need to pause the video, go ahead and do that. And here's what you should have had. You should have had 2x to the power of 3 plus x squared minus x. Okay. So, next one here. In C, where you've got x equals 2 and x equals 3 with a multiplicity of 2. Here's what's going to be different this time. Your two factors, you're going to have x minus 2 equals 0 and x minus 3 equals 0. So here's what's going to be kind of special about this case, is when you list those out, x minus 3, because it has a multiplicity of 2, means that it happens twice. You can either write it out twice as x minus 3 and then another x minus 3 over here, or you can just put an exponent of 2 here. Either way works for factored form. Now, for standard form, it's probably best to rewrite this instead of using an exponent of 2 as an exponent of, well, not an exponent at all, but to list it out as x minus 3, x minus 3. That way you remember to distribute when you start to multiply it out. Once again, I want you to pause the video if you need to, multiply all of this out, and then check your answer in just a second. Alright, here's what you should have had. Should have had x to the power of 3 minus 8x to the power of 2 plus 21x minus 18. Okay. For D, here we go. So, one factor, x plus 2 equals 0. Second factor, x minus 3i equals 0. What that means, if x minus 3i is equal to 0, we have to use the complex conjugate root theorem to say that x plus 3i, the conjugate, would also need to equal 0, meaning that you're going to have two factors here. So when you list out your polynomial in factored form, the only thing you need to be careful of is just making sure you apply that theorem to make sure that you have complex roots which come in pairs with their conjugate. Alright, so once again, multiply this out and check your answer in a little bit. My one suggestion would be this. Multiply your complex part out first. That way, you get rid of the complex numbers, and that way you can focus on just the real number coefficients. Now, again, it does not matter the order, but just know that starting with your complex part will make it just a little bit easier. All right, go ahead and pause it and then check your answer in just a little bit. Here's what you should have had for final answer. Should have had x to the power of 3 plus 2x to the power of 2 plus 9x plus 18. All right, one more. Here we go. So for E, here's what we start with. We start with x equals the square root of 5 and x equals 2. So at least right now, my two factors, when I get them to be equal to 0, x minus the square root of 5 is equal to 0, and x minus 2 equals 0. Now, here's where the rational root theorem applies. If you have x minus the square root of 5 as a factor, then x plus the square root of 5 would also need to be a factor here. All right, so when you write out your polynomial, I like to write my two different pieces that are the irrational pieces with radicals together. And remember, order doesn't matter. You can always reorder them, but it just does make it a little easier when you multiply, and you'll see why in just a little bit. But I would write those next to each other. And then similar to how we've multiplied the complex part together first, my suggestion would be when we write our polynomial in standard form, multiply all of this first. Now, again, it does not matter. You'll get the same answer either way. Just a suggestion as far as looking at that. Okay. So, here's what you should have for final answer. Pause the video if you're not ready for it, but you should have had x to the power of 3 minus 2x to the power of 2 minus 5x plus 10. Alright, so if there are any of those that in standard form you got something different than me, in the notes on Schoology, which are just a little bit different, I have written out the step-by-step of distributing. That way you can maybe see where maybe you made a mistake somewhere. That way you can check your work. Just as a few reminders, for Wednesday when I see you again, make sure that you have the homework done, which is worksheet 6.2. Both that worksheet as well as answer key are already on Schoology. So worksheet 6.2 is due on Wednesday. Make sure you get that done. Also for Wednesday, freshmen, make sure you eat a good breakfast. Make sure you have MacBook fully charged. You are taking the MAT test on Wednesday. Sophomores, you should also be eating a good breakfast and make sure you have MacBook fully charged. You are taking the KITE interim assessment, which is getting you ready for the Kansas State assessment. Juniors, you get to kind of luck out. What you are going to be working on, you are going to get kind of a head start on the project that we are going to be working with. So it would be in your best interest to have your polynomial kind of picked out. And if you don't, then you really need to use Wednesday to get that polynomial picked out for our roller coaster project that we're going to be using as our test here. All right, guys, that is it for today. Have a great rest of your Tuesday, and I will see you tomorrow.